Hello there, and welcome to the Sleepy Library. Tonight, we are drifting into one of the ocean's most talked about regions, a place where legend and reality have danced together for decades, creating stories that have captured imaginations around the world. The Bermuda Triangle. A name that conjures mystery, wonder, and endless questions. But tonight, we will not chase sensational tales or impossible theories. Instead, we will explore the truth, the gentle science, and the fascinating reality of this remarkable stretch of ocean. We will discover that the real story is far more interesting than fiction, filled with natural wonders, ocean currents, and the simple beauty of understanding how our world actually works. So, settle in, let your breathing slow, and prepare for a journey through warm waters, scientific discovery, and the quiet truth that lies beneath the waves. Let's begin. The Bermuda Triangle does not officially exist on any map. If you were to look at a nautical chart or consult official geographic records, you would search in vain for a place marked as the Bermuda Triangle. The United States Board on Geographic Names does not recognize it. The US Navy does not acknowledge it as a special hazard zone. Even maritime insurance companies, those meticulous assessors of risk and danger, do not charge higher premiums for ships passing through this region. The Bermuda Triangle is what we might call a cultural construct, an idea that grew from stories, articles, and books, rather than from official designation or scientific evidence. It exists in our collective imagination far more vividly than it exists in the ocean itself. And yet, when people speak of the Bermuda Triangle, they generally agree on its rough boundaries. The region forms a loose triangle in the western part of the North Atlantic Ocean. Its 3 points are usually said to touch Miami, Florida, on the western edge. Bermuda, that beautiful island territory, marks the northern apex, and the 3rd point reaches down to San Juan, Puerto Rico, in the south. Depending on who is drawing the boundaries, the area can encompass anywhere from 500,000 to 1.5 million square miles of ocean. That is an enormous expanse of water, roughly equivalent to the size of Alaska, or about 3 times the size of Texas. It is a vast theater of ocean, sky, and movement. Within this imaginary triangle lies some of the most traveled shipping lanes in the entire world. Thousands of vessels pass through these waters every single year. Cruise ships carrying vacationers to tropical islands, cargo ships laden with goods traveling between the Americas and Europe, fishing boats, private yachts, Coast Guard cutters, and commercial aircraft following routes that have been established for decades. The skies above hum with air traffic. The waters below pulse with the movement of trade and travel. It is one of the busiest maritime corridors on the planet, a crossroads where the Atlantic meets the Caribbean, where warm waters mingle with ocean currents, and where human activity has flowed for centuries. The very name Bermuda Triangle did not enter common usage until the 1960s. Before that, sailors and pilots passed through these waters without any particular sense that they were entering a zone of danger or mystery. The phrase was coined in 1964 by a writer named Vincent Gaddis. In a magazine article for a pulp publication called Argosy, Gaddis wrote about strange disappearances of ships and aircraft in this region. He called it the Deadly Bermuda Triangle, and the name caught fire in the public imagination. Soon other writers picked up the theme, adding their own accounts, theories, and embellishments. By the 1970s, the Bermuda Triangle had become a household name, synonymous with unexplained vanishings and supernatural mystery. But here is something relaxing to consider as you drift towards sleep. The legend of the Bermuda Triangle grew not from an accumulation of verified facts, but from a series of mistakes, exaggerations, and selective storytelling. In 1975, a researcher named Larry Kusch published a book that would change the conversation forever. The book was called The Bermuda Triangle Mystery Solved. Kusch was a reference librarian who decided to investigate the disappearances that had been attributed to the triangle. He went back to original sources, newspaper archives, Coast Guard records, and Navy reports. He meticulously fact-checked every major incident that had been used to build the legend. And what he found was remarkable in its simplicity. Many of the disappearances that had been blamed on the Bermuda Triangle had actually occurred nowhere near the triangle at all. Some happened hundreds or even thousands of miles away. In other cases, ships that were reported as mysteriously vanished had actually been found safe and sound, but that detail had never made it into the sensational retellings. Weather conditions that should have been mentioned were conveniently left out of the stories. Storms, hurricanes, and rough seas were ignored in favor of tales of calm disappearances on clear days. Details were changed, dates were wrong, and in some instances, the ships or planes in question had never existed at all. They were inventions, fictional elements added to make the mystery more compelling. Kusch's research revealed something profound and actually quite comforting. When you strip away the embellishments and examine the actual evidence, the Bermuda Triangle does not have an unusually high rate of disappearances at all. In fact, given the volume of traffic that moves through this region every day, the number of incidents is entirely normal. Ships and planes go missing in oceans all over the world. It is a sad reality of maritime and aviation travel. But it happens at roughly the same rate everywhere, whether in the Atlantic, the Pacific, the Indian Ocean, or the Mediterranean Sea. The Bermuda Triangle is not special in this regard. It is simply a busy part of the ocean that happens to have been given a memorable name. The National Oceanic and Atmospheric Administration, known as NOAA, has stated clearly and without ambiguity that there is no evidence that mysterious disappearances occur with any greater frequency in the Bermuda Triangle than in any other large, well-traveled area of the ocean. The US Coast Guard echoes this assessment. In their official statements, they note that they do not recognize the Bermuda Triangle as a place where unusual phenomena occur. They attribute disappearances in the region to the same causes that account for losses anywhere else on the sea: poor weather, navigational error, mechanical failure, human mistake. These are the realities of ocean travel, and they apply equally whether you are sailing off the coast of California or flying over the waters between Florida and Bermuda. In 2013, the World Wildlife Fund conducted an exhaustive study of the world's most dangerous waters for shipping. They identified the 10 bodies of water where maritime accidents occur most frequently. The Bermuda Triangle did not make the list, not even close. The real danger zones, statistically speaking, are places like the South China Sea, the East China Sea, and the waters around the Mediterranean. These are regions where heavy traffic, narrow passages, political instability, and frequent storms create genuinely hazardous conditions for ships. The Bermuda Triangle, by contrast, is simply a normal patch of ocean. Let us talk about the ocean itself, because understanding the natural features of this region helps us see why some incidents have occurred here and why they are entirely explainable. The waters of the Bermuda Triangle are part of the North Atlantic, an ocean known for its depth, its currents, and its variable weather. The seafloor in this region is not uniform. In some places, it is relatively shallow, with coral reefs and sandbars that compose hazards to navigation. In other areas, the ocean plunges into profound depths. Near the southern edge of the triangle, close to Puerto Rico, lies the Puerto Rico Trench, one of the deepest parts of the Atlantic Ocean. This trench descends more than 27,000 feet below the surface, deeper than Mount Everest is tall. The Milwaukee depth, which is located within the Bermuda Triangle, reaches even further down, making it the deepest point in the entire Atlantic. These depths are important to understand because they help explain why wreckage from ships or planes might never be found. When something sinks in shallow coastal waters, it is often possible to locate and recover it. But when a vessel goes down in waters that are 5 or 6 miles deep, it becomes extraordinarily difficult to find. The ocean floor at these depths is a dark, cold, and pressurized environment. Debris can be scattered across vast areas. Currents can move wreckage far from where it originally sank. Sediment can cover remains within days or weeks. The simple fact is that the ocean is very good at hiding things. This is not mysterious. It is just the reality of deep water. Running through the Bermuda Triangle is one of the most powerful ocean currents in the world, the Gulf Stream. This warm, fast-moving river within the ocean originates in the Gulf of Mexico, flows through the Straits of Florida, and then sweeps northward along the eastern coast of the United States before turning eastward across the Atlantic toward Europe. The Gulf Stream is a remarkable force of nature. It moves at speeds that can reach 4 to 5 miles per hour, which may not sound fast until you consider that this is a river of water hundreds of miles wide and hundreds of feet deep, carrying an immense volume of warm tropical water toward higher latitudes. For ships and planes, the Gulf Stream can be both a help and a challenge. Sailors have long used it to speed their journeys northward, but the current can also cause problems. It can push a vessel off course if navigators do not account for its drift. In the days before precise GPS navigation, this could lead to serious errors in position. A ship that thought it was heading due north might actually be moving northeast, carried by the invisible hand of the current. If that ship then encountered trouble, search and rescue teams might look in the wrong place entirely, based on where the ship was supposed to be, rather than where the current had actually taken it. The Gulf Stream also contributes to the weather in this region. Where warm water meets cooler air, or where the current interacts with winds and atmospheric pressure systems, the conditions can change rapidly. A clear, calm day can give way to squalls and rough seas with remarkable speed. Waterspouts, those tornado-like columns of rotating air and water, can form suddenly over the ocean. These are not supernatural phenomena. They are well-documented weather events that occur in many parts of the world, particularly in tropical and subtropical waters. But for a small boat or a low-flying aircraft, a waterspout can be dangerous and disorienting. The Bermuda Triangle sits in a region that experiences frequent tropical storms and hurricanes. The Atlantic hurricane season runs from June through November, and during these months, powerful storms regularly form in the warm waters of the Caribbean and the Gulf of Mexico before moving northward. Some of these storms pass directly through the area we call the Bermuda Triangle. In the days before weather satellites and advanced forecasting, ships and planes had little warning when a hurricane was approaching. They might set out under clear skies, only to find themselves hours later in the midst of a violent storm. Hurricanes bring torrential rain, winds that can exceed 150 miles per hour, and waves that can tower 30 or 40 feet high. These are conditions that can overwhelm even modern vessels. For older ships with less advanced technology, survival in such a storm was far from guaranteed. One of the most famous incidents associated with the Bermuda Triangle is the disappearance of Flight 19. This event occurred on December 5, 1945, just a few months after the end of World War II. 5 TBM Avenger torpedo bombers took off from the Naval Air Station in Fort Lauderdale, Florida, on what was supposed to be a routine training flight. The mission was called Navigation Problem Number 1, a standard exercise that had been flown many times before. The plan was straightforward. The planes would fly east from Florida, conduct practice bombing runs at a place called Hens and Chickens Shoals, then turn north to fly over Grand Bahama Island, and finally head southwest back to base. The entire flight was expected to take about 3 hours. The flight was led by Lieutenant Charles Carroll Taylor, a naval aviator with 2,500 hours of flying experience and a combat tour in the Pacific Theater during the war. The other crew members were mostly trainees, young men who had recently completed their basic flight instruction. In all, 14 men were aboard the 5 aircraft. The flight began smoothly. The planes took off on schedule and proceeded to their bombing practice area without incident. They dropped their practice bombs and began the second leg of the journey, turning north as planned. But then something went wrong. About 90 minutes into the flight, radio operators at the Fort Lauderdale Air Station began to hear confused transmissions from the flight leader. Lieutenant Taylor reported that his compasses were not working properly and that he was unsure of his position. He thought he was over the Florida Keys, far to the west of where he actually was. Other pilots in the flight reported similar compass problems. As time went on, the transmissions became more fragmented and harder to understand. Taylor believed he was over the Gulf of Mexico and tried to navigate by heading northeast, thinking this would bring him to the Florida coast. In reality, he was over the Bahamas, and heading northeast was taking the flight farther out into the Atlantic Ocean, away from land. Efforts were made to guide the flight back to safety. Radio operators tried to provide directions. Other aircraft in the area attempted to assist. But the weather was deteriorating. A storm front was moving in, bringing rain and clouds. As darkness fell, the situation became more desperate. The last coherent transmission from Flight 19 was heard around 7 in the evening. After that, silence. A search and rescue mission was launched immediately. One of the rescue planes, a PBM Mariner flying boat, took off to look for the missing flight. This plane too disappeared. It never returned to base, and no wreckage was ever found. In all, 27 men vanished that night. The official Navy investigation into the loss of Flight 19 concluded that Lieutenant Taylor had become disoriented due to compass malfunction and had led the flight in the wrong direction. The planes eventually ran out of fuel and were forced to ditch in the ocean. The Avengers were heavy aircraft, and ditching at sea, especially at night and in rough weather, would have been extremely difficult. It is likely that the planes sank quickly. As for the PBM Mariner, these aircraft were known to have a dangerous flaw. Their fuel lines could become loose, and if gasoline leaked into the fuselage and encountered a spark, the plane could explode in mid-air. An explosion would leave little wreckage and would explain why nothing was ever found. Over the years, the story of Flight 19 has been retold many times, often with details that were not part of the original account. Some versions claim that the pilots reported seeing strange lights, or that the ocean did not look right. These dramatic additions do not appear in the actual radio transcripts or official reports. The reality, while tragic, is far more mundane. Navigational error, compass failure, worsening weather, and running out of fuel are explanations that fit all the known facts. There is no need to invoke anything mysterious or supernatural. Another frequently cited case is the disappearance of the USS Cyclops, a massive naval cargo ship that vanished in March of 1918 during World War I. The Cyclops was an enormous vessel, over 540 feet long, with a crew of more than 300 men and a cargo of 10,000 tons of manganese ore. The ship left Barbados on March 4th, bound for Baltimore, Maryland. It never arrived. No distress signal was ever sent, despite the fact that the ship was equipped with radio. No wreckage was ever found. No survivors were ever located. The Cyclops simply vanished, along with everyone aboard, somewhere in the Western Atlantic. The loss of the Cyclops remains one of the great unsolved maritime mysteries. But it is important to note that 1918 was a time of war. German submarines were active in the Atlantic, sinking ships without warning. The Cyclops was carrying a valuable cargo and would have been a tempting target. However, there is no evidence that a submarine attacked it. Another possibility is structural failure. The Cyclops was loaded with an extremely heavy and dense cargo of manganese ore. If the cargo shifted suddenly in rough seas, it could have caused the ship to capsize and sink rapidly, giving the crew no time to send a distress call. The waters in this part of the Atlantic can be very deep, and a large ship that sinks in such depths may never be found. What is often overlooked in discussions of the Cyclops is that two of its sister ships also disappeared under similar circumstances in the 1940s. The Proteus and the Nereus both vanished without a trace while carrying similar cargoes. This pattern suggests that there may have been a design flaw in these particular ships, something about their structure or the way they were loaded that made them vulnerable to sudden disaster. This is not mysterious, it is engineering, cargo management, and the sometimes unpredictable behavior of the sea. Beyond these well-known cases, many other disappearances have been attributed to the Bermuda Triangle over the years. But when researchers like Larry Kusch examined these incidents closely, they found that the vast majority had straightforward explanations. Ships that were reported as vanishing on calm seas had actually disappeared during hurricanes. Aircraft that were said to have vanished with no warning had experienced known mechanical problems before takeoff. In some cases, the so-called missing vessels were simply delayed and turned up safe at a later date. But by then, the story of their mysterious disappearance had already entered the lore of the Triangle. Human error plays a significant role in many maritime and aviation accidents. Navigating the open ocean is not easy. Before the advent of GPS satellites, sailors relied on compasses, sextants, and dead reckoning to determine their position. Even experienced navigators could make mistakes, especially when weather interfered with their ability to take sightings of the sun or stars. In the Bermuda Triangle, there is an additional complication. This region is one of the few places on Earth where, at certain times, the difference between magnetic north and true north can be very small or even non-existent. This is called the agonic line, the place where a compass points to true north rather than magnetic north. For sailors who did not understand this phenomenon or failed to account for it, this could lead to navigational confusion. Imagine a pilot or ship captain who has learned to adjust for the difference between magnetic and true north. They have been trained to do this throughout their career. But now they enter a region where that adjustment is no longer necessary, and they do not realize it. They continue to correct their course as they always have, and in doing so, they actually steer themselves off course. Over time, this error compounds. What starts as a small mistake becomes a significant deviation. By the time they realize something is wrong, they may be far from where they thought they were. In the vastness of the ocean, being off by even a few degrees can mean the difference between reaching land safely and becoming lost at sea. The weather in the Bermuda Triangle, while not uniquely dangerous, is certainly variable and can be challenging. The region experiences what meteorologists call white squalls, sudden and intense storms that can appear with little warning. These squalls are characterized by strong, shifting winds and heavy rain. The name comes from the white appearance of the sea surface whipped up by the wind. For a small boat caught in a white squall, the experience can be terrifying. Waves can grow from manageable to dangerous in a matter of minutes. Visibility drops to nearly zero, and because these squalls can form quickly, they may not be detected by weather forecasts until it is too late for ships to take evasive action. Waterspouts are another weather phenomenon common to this region. A waterspout is essentially a tornado over water, a rotating column of air that extends from a cloud down to the ocean surface. They are most common in tropical and subtropical waters, particularly during the warmer months. Most waterspouts are relatively weak and short-lived, but they can still pose a danger to boats and low-flying aircraft. A plane that flies into or near a waterspout can experience severe turbulence. A small boat beneath one can be swamped by the intense winds and churning water. Waterspouts are well documented and understood by meteorologists. They are not paranormal events. They are simply part of the weather patterns in warm ocean environments. Hurricanes, as mentioned earlier, are a regular feature of the Atlantic from June through November. These massive storms can span hundreds of miles and generate winds powerful enough to tear roofs off buildings and push water into storm surges that flood coastlines. At sea, hurricanes create towering waves and conditions that are almost impossible to survive without the right preparation and equipment. In the era before satellite weather monitoring, ships and planes often had no way of knowing a hurricane was approaching until they were already in the outer bands of the storm. By then, escape might be impossible. Even today, with all our advanced technology, mariners and pilots treat hurricanes with the utmost respect and do everything they can to avoid them. Now, let us consider the ocean floor beneath the Bermuda Triangle, because it holds clues to why wreckage might never be found. The Atlantic Ocean in this region is not a flat, featureless plain. It is a landscape of ridges, valleys, and trenches. Coral reefs rise in some areas, creating hazards for ships that venture too close. In other places, the seabed drops away into abyssal depths. The Puerto Rico Trench, which lies near the southern edge of the triangle, is a chasm in the Earth's crust, where one tectonic plate is sliding beneath another. This trench is over 8,000 meters deep in places, a depth so profound that if you placed Mount Everest at the bottom, its peak would still be more than a mile below the surface. When something sinks in such deep water, it enters a world that is utterly dark, crushingly cold, and under immense pressure. At these depths, there is no light from the sun. The temperature hovers just above freezing. The pressure is hundreds of times greater than at the surface, enough to crush most human-made objects. Exploring these depths requires specialized equipment, remotely operated vehicles, and significant resources. Even with modern technology, searching the deep ocean floor is slow, expensive, and often unsuccessful. It is like searching for a needle in a haystack, except the haystack is miles deep and pitch black. The Gulf Stream, that powerful current we discussed earlier, also plays a role in scattering debris. When a ship or plane goes down, pieces of wreckage may float for a time before sinking. But the Gulf Stream can carry floating debris dozens or even hundreds of miles from the actual site of the accident. By the time search and rescue teams arrive, the wreckage may have drifted far from where they are looking. Over the following days and weeks, currents, tides, and waves continue to disperse the debris. Some pieces sink, others wash ashore on distant beaches. Still others are carried out into the open Atlantic, where they may never be found. This is not a mystery. It is simply the ocean doing what oceans do, moving and redistributing everything within them. There have been theories over the years that try to explain Bermuda Triangle disappearances with unusual or exotic phenomena. One such theory involves methane gas. The idea is that large pockets of methane hydrate, a form of natural gas trapped in ice-like structures on the ocean floor, could suddenly release and bubble up to the surface. If enough methane rose through the water, it could theoretically reduce the density of the water, causing a ship to lose buoyancy and sink rapidly. Experiments in laboratories have shown that this is physically possible under certain conditions. However, studies by the United States Geological Survey have found no evidence of significant methane releases in the Bermuda Triangle area for at least the past 15,000 years. While methane hydrates do exist in many parts of the world's oceans, there is no indication that they are releasing in quantities large enough or suddenly enough to pose a threat to ships in this region. It is a scientifically interesting idea, but it does not match the actual evidence. The methane theory, while it sounds plausible and has captured the popular imagination, does not hold up under scrutiny. Another theory that has been proposed involves magnetic anomalies. The idea here is that unusual magnetic fields in the Bermuda Triangle could interfere with compasses and navigation equipment, causing pilots and sailors to become disoriented. While it is true that magnetic fields can affect compasses, there is no evidence of any unusual magnetic anomalies in the Bermuda Triangle. The Earth's magnetic field varies naturally across the surface of the planet, but the variations in the Bermuda Triangle are no different from those in other parts of the ocean. The agonic line, where magnetic north and true north align, does pass through this region. But as we have discussed, this is a known and understood phenomenon. It can cause confusion if navigators are not aware of it, but it is not an anomaly or a mystery. Over the decades, more sensational theories have been proposed as well. Some writers have suggested that the Bermuda Triangle is a portal to another dimension, a place where the fabric of space and time becomes thin and allows objects to slip into parallel universes. Others have claimed that the area is a hotspot for UFO activity, that extraterrestrial beings are abducting ships and planes for unknown purposes. Still others have connected the triangle to the legendary lost city of Atlantis, suggesting that ancient technology or crystals beneath the sea are interfering with modern navigation. These ideas make for entertaining stories, and they have appeared in countless books, television shows, and movies. But they are not supported by any evidence. They rely on speculation, imagination, and a willingness to set aside the principles of science and reason. There is no physical evidence of portals, no verified accounts of alien abductions in this region, and no archaeological findings that support the existence of Atlantis beneath the waves of the Bermuda Triangle. What these theories do reveal is something interesting about human nature. We are drawn to mystery. We enjoy the thrill of the unknown. And sometimes, we prefer a dramatic, fantastical explanation over a simple, factual one. The truth about the Bermuda Triangle is that it is an ordinary part of the ocean made extraordinary by storytelling. It is a place where the same natural forces that operate everywhere else on Earth also operate here. Wind and waves, currents and storms, human error and mechanical failure. These are the realities of travel by sea and air, and they apply whether you are crossing the Atlantic near Bermuda or the Pacific near Hawaii. The Bermuda Triangle is not cursed. It is not haunted. It is not a gateway to other worlds. It is simply ocean. And there is something deeply relaxing about this realization. The world does not need to be filled with inexplicable mysteries for it to be interesting. The natural world, understood through science and careful observation, is endlessly fascinating on its own. The power of a hurricane, the flow of a massive ocean current, the depth of an undersea trench. These are marvels in their own right. They do not require embellishment or exaggeration to be worthy of our attention and respect. As you continue to drift towards sleep, consider the ships and planes that pass through the Bermuda Triangle every single day. Cruise ships filled with families on vacation, cargo vessels carrying goods from one continent to another, fishing boats seeking their catch, aircraft tracing routes across the sky. They move through this region without incident, guided by GPS satellites, informed by weather forecasts, protected by modern engineering and safety protocols. The Bermuda Triangle is one of the most heavily traveled parts of the ocean, and the vast majority of journeys through it are completely routine and uneventful. The ocean itself, in this region, is a place of beauty. The waters are warm and a brilliant shade of blue, colored by the tropical sunlight and the way it scatters through the clear, deep water. Coral reefs, where they exist in shallower areas, are home to vibrant ecosystems of fish, sea turtles, and countless other forms of marine life. The islands within and around the triangle, places like Bermuda, the Bahamas, and Puerto Rico, are known for their stunning beaches, lush vegetation, and welcoming climates. This is not a place of darkness and dread. It is a place of light and life. Scientists have conducted surveys of the ocean floor in the Bermuda Triangle, and what they have found is not mysterious wreckage or alien artifacts, but rather the expected diversity of deep-sea life. In 2006, a research cruise explored waters as deep as 3 miles beneath the surface in this region. They collected samples of tiny zooplankton, shrimp-like creatures, small squid, jellyfish, and other organisms. Over 1,000 different species were identified, many of them new to science. These surveys revealed that the deep waters of the Bermuda Triangle are teeming with life, just as they are in other parts of the ocean. The creatures that live in these depths are adapted to the darkness and pressure, using bioluminescence to create light, filtering nutrients from the water, and existing in an ecosystem that operates entirely without sunlight. The Gulf Stream, which we have mentioned several times, is not only important for understanding navigation and disappearances, it is also a critical component of the Earth's climate system. This current carries warm water from the tropics toward the poles, helping to distribute heat around the planet. The warmth brought by the Gulf Stream moderates the climate of Western Europe, making it significantly warmer than other regions at the same latitude. Without the Gulf Stream, the climate of the entire North Atlantic region would be very different. Understanding this current has been important for scientists studying climate patterns, ocean circulation, and the way energy moves through the Earth's systems. Beneath the waters of the Bermuda Triangle, geologists have studied the structure of the ocean floor and the processes that shape it. The Puerto Rico Trench, for example, is a subduction zone where the Caribbean plate is being pushed beneath the North American plate. This is a region of active geology, where earthquakes can occur and where the Earth's crust is constantly being reshaped. Studying these features helps scientists understand plate tectonics, the theory that explains how the Earth's outer shell is divided into massive pieces that move and interact over millions of years. The Bermuda Triangle, far from being a place of paranormal activity, is a place where normal, natural geological processes are at work. The history of navigation through this region stretches back centuries. Christopher Columbus sailed through what we now call the Bermuda Triangle on his first voyage to the New World in 1492. In his logs, he noted some unusual observations. He wrote about strange compass readings and seeing a light in the sky one night. These accounts have sometimes been cited as evidence of mysterious forces in the triangle. But when you read Columbus's journals more carefully, the explanations become clear. The compass readings he found unusual were likely due to the agonic line, which we have already discussed. The light in the sky may have been a meteor, a distant fire on a shoreline, or any number of other ordinary phenomena. Columbus was sailing into unknown waters, and he was naturally alert to anything that seemed out of the ordinary. But his observations do not point to anything supernatural. In the centuries that followed, countless ships crossed these waters. Spanish treasure fleets carrying gold and silver from the New World back to Europe, British and French naval vessels, merchant ships laden with goods, pirate ships hunting for prizes. This has always been a busy part of the ocean, a highway of commerce and exploration. Some ships were lost, to be sure. Some fell victim to storms. Others were captured by pirates or enemy navies. Some ran aground on reefs or were wrecked by navigational error. But these losses were understood in the context of the times. They were the risks of sea travel, accepted as part of the cost of doing business on the ocean. It was only in the 20th century, with the rise of mass media and popular culture, that the Bermuda Triangle became something more than just another patch of ocean. Magazine articles in the 1950s and 60s began to compile lists of disappearances, often without checking whether those disappearances had actually occurred in the triangle or whether they remained unexplained. Books in the 1970s, particularly Charles Berlitz's bestseller, The Bermuda Triangle, brought the legend to a global audience. Berlitz's book was filled with dramatic accounts and speculative theories, but it was light on rigorous research and fact-checking. Many of the stories in the book have since been debunked or shown to be exaggerated. Yet, the book sold millions of copies and cemented the Bermuda Triangle as a fixture of popular culture. What is striking in retrospect is how quickly a myth can be built and how difficult it can be to dismantle once it has taken hold. Even today, decades after researchers like Larry Kusch demonstrated that the Bermuda Triangle is no more dangerous than any other part of the ocean, the legend persists. People continue to write books about it, make documentaries about it, and debate its mysteries online. There is something about the human mind that is drawn to the idea of hidden dangers and unsolved puzzles. We want to believe that there are places in the world that defy explanation, that remind us how little we truly know. But the opposite is also true. There is something deeply satisfying about understanding the world through science and reason. When we take the time to investigate, to gather evidence, to think critically, we often find that the mysteries dissolve. What seemed inexplicable becomes clear. What felt frightening becomes manageable. And in that clarity, there is a kind of peace. The Bermuda Triangle is not a threat. It is a reminder that the world operates according to natural laws that we can study, understand, and predict. As you lie here, breathing slowly, letting go of the day, think about the ocean as it truly is. Not as a place of supernatural danger, but as a vast and dynamic environment shaped by physics, chemistry, and biology. The waves that rise and fall are moved by the wind and the pull of the moon. The currents that flow beneath the surface are driven by differences in temperature and salinity, by the spinning of the earth, and by the shape of the ocean basins. The storms that occasionally rage across the water are the result of moisture, heat, and atmospheric pressure interacting in ways that meteorologists can model and predict. All of this is natural. All of this is understandable. The ships and planes that have been lost in the Bermuda Triangle met their ends not because of curses or alien intervention, but because of the same forces that cause losses in any ocean. Bad weather caught them unprepared. Navigation errors led them astray. Mechanical failures left them vulnerable. In some cases, we may never know exactly what happened. The ocean is vast, and it keeps its secrets well. But the absence of an explanation is not proof of the supernatural. It is simply a reminder of the limits of our knowledge and the difficulty of finding answers in an environment as challenging as the open sea. There is a kind of poetry in this, a quiet beauty in the fact that the ocean remains in many ways a frontier. Even with all our technology, satellites and research vessels, there are depths we have not yet explored, currents we are still mapping, and species we have not yet discovered. The ocean is not a solved puzzle. It is an ongoing mystery, but a natural one. And that makes it no less wondrous. The wildlife that inhabits the waters of the Bermuda Triangle is as diverse and fascinating as that found in any tropical ocean region. Coral reefs, where they grow in the shallower waters around islands and along continental shelves, create entire cities of life beneath the waves. These reefs are built by tiny animals called coral polyps, creatures no bigger than a fingernail that live in vast colonies. Over decades and centuries, these polyps secrete calcium carbonate, building the hard structures that form the reef. The result is a three-dimensional habitat full of caves, crevices, and colorful formations that house an astonishing variety of creatures. Swimming among the coral are fish of every imaginable color and pattern. Parrotfish, with their brilliant blues and greens, use their beak-like mouths to scrape algae from the coral surface. Angelfish glide gracefully, bodies adorned with stripes and spots. Schools of silvery fish move in synchronized waves, creating living sculptures that shift and flow with the currents. Sea turtles, ancient mariners that have swum these waters for millions of years, come to the reefs to feed on sponges and seagrass. There are 4 species of sea turtle that frequent the waters of the Bermuda Triangle: the green turtle, the hawksbill, the loggerhead, and the enormous leatherback, which can weigh over 1,000 pounds and dive to depths of more than 3,000 feet. The larger creatures of these waters are equally remarkable. Dolphins, those intelligent and playful mammals, travel in pods through the Bermuda Triangle. The bottlenose dolphin is particularly common here, recognizable by its friendly appearance and curious nature. These dolphins communicate with each other through a complex language of clicks, whistles, and body movements. They hunt cooperatively, working together to herd schools of fish into tight balls before taking turns feeding. Sometimes, if you are fortunate enough to be on a boat in these waters, dolphins will approach to ride the bow wave, leaping and spinning in what can only be described as pure joy. Whales also pass through this region, migrating along routes that have been followed for countless generations. Humpback whales travel through the waters between their feeding grounds in the North Atlantic and their breeding areas in the Caribbean. These massive creatures, which can grow to 50 feet in length and weigh 40 tons, are known for their haunting songs and acrobatic breaches. To see a humpback whale leap entirely out of the water and crash back down in an explosion of spray is to witness one of nature's most spectacular displays. The North Atlantic right whale, one of the most endangered large whale species, also moves through these waters. Tragically, these whales were hunted nearly to extinction, and today fewer than 400 individuals remain. Beneath the surface, in the deeper waters beyond the reefs, different forms of life thrive. The deep sea is a realm of perpetual darkness, where sunlight never penetrates. Here, creatures have evolved remarkable adaptations to survive. Bioluminescence, the ability to produce light through chemical reactions, is common among deep-sea organisms. Fish with glowing lures dangle appendages in front of their mouths to attract prey. Jellyfish pulse with ethereal blue or green light as they drift through the water column. Tiny zooplankton create clouds of sparkles when disturbed, a phenomenon that can sometimes be seen from the surface on dark nights when the sea seems to glow with an otherworldly radiance. The deep waters of the Bermuda Triangle are home to creatures that seem almost alien in their appearance. Gulper eels have mouths that can open to enormous proportions, allowing them to swallow prey larger than themselves. Viperfish bristle with long, needle-like teeth and possess light, producing organs along their bodies. Giant squid, the legendary creatures that inspired countless sea monster tales, hunt in the depths with eyes the size of dinner plates and tentacles lined with powerful suckers. While encounters with giant squid are rare, scientists have learned much about them in recent decades through the study of dead specimens that wash ashore or are caught accidentally in fishing nets. The ocean floor in the Bermuda Triangle, particularly in the deeper regions, is covered with a soft sediment made up of the remains of countless tiny organisms. When these microscopic creatures die, their shells and skeletons drift down through the water column, accumulating over millions of years into layers that can be hundreds of feet thick. This sediment, called ooze, is a kind of archive of ocean history. Scientists who study cores of sediment taken from the seafloor can read the record of past climates, ocean temperatures, and even the types of creatures that lived in the water above at different times in Earth's history. Scattered across the seafloor are also hydrothermal vents, places where heated water from beneath the Earth's crust rises up and creates oases of life in the otherwise barren deep. These vents were only discovered in the late 1970s, and they revealed entire ecosystems that exist independently of sunlight. The organisms living around hydrothermal vents derive their energy not from photosynthesis, but from chemosynthesis, using chemicals in the vent fluids as a source of energy. Giant tube worms, some growing to 8 feet in length, cluster around the vents. Blind shrimp, white crabs, and unique species of fish make their homes in this harsh but productive environment. The Caribbean islands that mark the southern boundary of the Bermuda Triangle are themselves products of volcanic and tectonic activity. Puerto Rico, the largest of these islands, sits on the edge of the Caribbean plate. The island is mountainous and lush, covered in tropical rainforest and surrounded by beaches of fine sand. The Puerto Rico Trench, which we have mentioned before, lies just to the north of the island. This trench is not only a geological feature of interest to scientists, but also a reminder of the dynamic nature of our planet. The crust beneath the ocean is constantly moving, shifting, and reshaping itself over timescales that dwarf human experience. Bermuda itself, the island that gives the triangle one of its 3 points, is a fascinating place with a unique ecology. Unlike the Caribbean islands, which are volcanic in origin, Bermuda is a coral island, sitting atop an extinct underwater volcano. The island is actually the visible peak of a seamount that rises from the ocean floor. Over millions of years, coral reefs grew on the slopes of this seamount, building up layers that eventually formed the land we see today. The climate of Bermuda is subtropical, warmed by the Gulf Stream that flows past its shores. This makes it one of the northernmost places in the world where coral reefs can grow. Bermuda is home to several species that are found nowhere else on Earth. The Bermuda petrel, also known as the cahao, is a seabird that was thought to be extinct for centuries. Early settlers on the island hunted the birds and introduced predators like rats and cats, which devastated the petrel population. By the early 1600s, no cahaos had been seen for so long that they were assumed to be gone forever. But in 1951, a small colony of breeding cahaos was discovered on remote rocky islets off the coast of Bermuda. Since then, conservationists have worked tirelessly to protect and increase the population. The cahao has become a symbol of successful conservation, a reminder that even species on the brink can recover if given protection and care. The Bermuda skink, a small lizard endemic to the island, is another species unique to this region. This sleek reptile has a shiny, coppery appearance and spends much of its time hiding under rocks and logs. Like the cahao, the Bermuda skink faced decline due to habitat loss and the introduction of invasive species. Conservation efforts are ongoing to ensure that this small creature does not disappear. The vegetation of Bermuda is also distinctive. The Bermuda cedar, a tree that once covered much of the island, is now threatened. In the 1940s, an invasive scale insect was accidentally introduced to Bermuda, and it spread rapidly through the cedar forests. Within a few years, millions of trees were dead. The loss of the cedar forests dramatically altered the island's landscape and ecosystem. Replanting efforts have brought some cedar trees back, but the forests have not returned to their former extent. The Bermuda palmetto, a small palm tree, still grows in a few protected areas, offering a glimpse of what the island's original forests might have looked like. The connection between the land and the sea in this region is intimate and vital. Nutrients washed from the islands feed the coastal waters, supporting the growth of plankton, which in turn supports fish, which feed larger predators. Mangrove forests, which grow along the edges of some Caribbean islands, serve as nurseries for young fish and protect coastlines from erosion. Birds that nest on the islands often feed far out at sea, diving for fish and squid. When they return to their nests, they bring nutrients from the ocean back to the land, fertilizing the soil and supporting plant growth. This exchange between ocean and land is a cycle that has continued for millennia. Within the boundaries of what we call the Bermuda Triangle lies another remarkable feature of the ocean, a place so unique that it is the only sea in the world without shores. This is the Sargasso Sea, a vast expanse of calm water bounded not by land but by 4 major ocean currents that circle around it in a clockwise motion. To the west flows the Gulf Stream we have already discussed. To the north runs the North Atlantic Current. The Canary Current marks the eastern boundary, and to the south, the North Atlantic Equatorial Current completes the circle. These currents form what oceanographers call a gyre, a massive rotating system of water that creates a kind of oceanic island in the middle of the Atlantic. The Sargasso Sea is enormous, covering approximately 2 million square miles of ocean. That is roughly the size of the entire continental United States, west of the Mississippi River. Bermuda sits near the western edge of this sea, the only substantial landmass within its boundaries. The waters of the Sargasso are remarkably clear and blue, some of the most transparent ocean waters anywhere on Earth. Visibility can extend to depths of 200 feet or more, allowing sunlight to penetrate far deeper than in most other parts of the ocean. This clarity comes from the fact that the Sargasso is essentially a desert in the ocean, a place where nutrients are relatively scarce compared to coastal waters or areas where cold, nutrient-rich currents well up from the depths. The Sargasso Sea gets its name from the floating golden-brown seaweed that covers large portions of its surface. This is sargassum, a type of brown algae that has evolved a remarkable adaptation. Unlike most seaweeds, which anchor themselves to rocks or the seafloor, sargassum floats freely on the ocean surface, kept afloat by small gas-filled bladders that dot its fronds like tiny balloons. Early Portuguese sailors who encountered this seaweed thought these bladders resembled small grapes, and they named the plant after the Portuguese word for grape. Columbus encountered vast mats of sargassum on his first voyage to the New World in 1492, and his sailors were both fascinated and frightened by it. The crew of the Santa Maria and her sister ships became becalmed in the Sargasso Sea for 3 days, caught in a region of light winds that is characteristic of this area. Sailors in those days knew that seaweed usually grows in shallow water near shores. So seeing such thick mats of floating vegetation in the middle of the ocean made them fear they were approaching hidden shoals or rocks that might tear the bottom out of their ships. They also worried that the seaweed might tangle their rudders or somehow trap them, preventing their return to Spain. These fears, recorded in Columbus's journals, contributed to the mystique of the Sargasso Sea and, centuries later, to the legends of the Bermuda Triangle. But the reality of Sargassum is far more wonderful than any legend. This floating seaweed creates an entire ecosystem, a drifting habitat that supports hundreds of species of animals in the middle of the open ocean. 2 species of Sargassum predominate in the Sargasso Sea, one with fine, delicate leaves and another with broader, lance-shaped fronds. Together, they form dense mats that can stretch for miles, creating what has been described as a golden floating rainforest, or a drowned meadow on the surface of the sea. These mats provide shelter, food, and breeding grounds for an astonishing diversity of life. Tiny shrimp, crabs, and other crustaceans live within the tangled fronds of Sargassum, their bodies often colored and patterned to match the seaweed, making them nearly invisible to predators. The Sargassum crab, found nowhere else in the world, has evolved specifically to live on this floating weed. Its coloring mimics the golden brown and yellow hues of the seaweed perfectly, allowing it to hunt small fish and invertebrates while remaining camouflaged. The Sargassum fish, another endemic species, is equally well adapted. This small fish has fins that have evolved to look like the fronds of seaweed, and it clings to the Sargassum with modified pectoral fins that act like hands. When danger approaches, it simply freezes in place and becomes indistinguishable from the plant it lives on. Juvenile fish of many species use Sargassum mats as nurseries. Baby tuna, dolphinfish, marlin, sailfish, and triggerfish all seek shelter in the seaweed during their early weeks and months of life. Here, hidden from larger predators and surrounded by a rich supply of tiny prey animals, these young fish grow and strengthen before eventually venturing out into the open ocean. Without the Sargassum, many of these species would have far lower survival rates, and the populations of some of the ocean's most important predatory fish would be much smaller. Sea turtles also depend on the Sargasso Sea. When loggerhead and green sea turtles hatch on beaches throughout the Atlantic, the tiny hatchlings make their way to the water and begin swimming frantically away from shore. These infant turtles, no bigger than the palm of your hand, are programmed by instinct to reach the Sargassum. They drift on ocean currents, sometimes for thousands of miles, until they find the floating mats of seaweed. There they spend what turtle biologists call the lost years, a period of time, often 5 to 10 years, during which the young turtles live in the open ocean and are almost never seen by humans. Hidden within the Sargassum, protected by the seaweed and camouflaged by their own coloring, the young turtles feed and grow. Only about 1% of turtle hatchlings survive to adulthood, and the Sargasso Sea plays a critical role in giving them a chance. The Sargasso is also the birthplace of eels. For centuries, one of the great mysteries of natural history was where European eels came from. These snake-like fish live in rivers, lakes, and streams throughout Europe. But no one had ever seen an eel egg or a baby eel in European waters. Adult eels would simply disappear from the rivers in autumn, and in spring, Tiny transparent eels, called glass eels, would appear at the mouths of rivers, swimming upstream to begin their lives in fresh water. Where did they come from? In the early 20th century, a Danish scientist named Johannes Schmidt solved the puzzle. He spent years collecting samples of eel larvae across the Atlantic, and he discovered that the smallest, youngest larvae were found in the Sargasso Sea. The European eel, it turns out, spawns in the deep waters of the Sargasso, thousands of feet below the surface. The larvae that hatch from these eggs drift on ocean currents for 2 to 3 years, slowly growing and gradually making their way across the entire Atlantic Ocean to the coasts of Europe. There they transform into glass eels and swim up rivers, where they will spend the next 10 to 20 years growing to adulthood. When they are mature, they stop eating, turn silver, and begin the long journey back across the Atlantic to the Sargasso Sea to spawn and complete the cycle. It is one of the most extraordinary migrations in the animal kingdom. American eels follow a similar pattern, spawning in the Sargasso and then migrating to rivers along the east coast of North America. Both species are now endangered, threatened by habitat loss, overfishing, pollution, and dams that block their migration routes. Scientists are working to understand and protect these remarkable fish, and the Sargasso Sea is central to those efforts. Without the Sargasso, there would be no eels in the rivers of 2 continents. Seabirds also use the Sargasso Sea. Species like the royal tern and the laughing gull hunt for fish near sargassum mats, diving to catch small fish that congregate around the seaweed. The Manx shearwater, a seabird that breeds on islands off the coast of Wales, travels all the way across the Atlantic to feed in the Sargasso during the winter months. These birds are tireless flyers, spending most of their lives on the wing, gliding low over the waves and only coming to land to nest. The Sargasso provides them with a rich feeding ground in the middle of the ocean, a place where they can find enough food to sustain themselves during their long months at sea. Despite its importance as an ecosystem, the Sargasso Sea faces significant threats. Because it lies entirely in international waters, beyond the jurisdiction of any single country, it is difficult to protect. Commercial fishing takes place throughout the region. Ships dump waste and pollution as they pass through. And like many parts of the ocean, the Sargasso has become a collection point for plastic debris. The same currents that concentrate sargassum also concentrate floating trash. Scientists have found that the Sargasso contains high levels of microplastics, tiny fragments of plastic that can be ingested by fish, turtles, and other animals. These plastics can cause physical harm, blocking digestive systems or causing animals to feel full even though they have not eaten real food. They also carry toxic chemicals that accumulate in the tissues of animals and can be passed up the food chain. In recent years, governments and conservation organizations have begun working to protect the Sargasso Sea. The Sargasso Sea Commission was established in 2014 by Bermuda, the United States, the United Kingdom, and several other nations to promote the conservation and sustainable use of this unique ecosystem. There are proposals to designate the Sargasso as a marine sanctuary, giving it legal protections similar to that afforded to national parks on land. Such protection would help ensure that this remarkable sea continues to serve as a nursery for fish, a refuge for turtles, and a spawning ground for eels for generations to come. The Sargasso Sea also plays a role in producing oxygen for our atmosphere. Sargassum, like all photosynthetic organisms, produces oxygen as a byproduct of converting sunlight into energy. Estimates suggest that the sargassum in the Sargasso Sea produces billions of liters of oxygen every hour, making it one of the significant contributors to the oxygen we breathe. The ocean as a whole is responsible for producing more than half of the oxygen in Earth's atmosphere, and floating seaweeds like sargassum are an important part of that process. There is something deeply comforting about learning that the so-called mysteries of the Bermuda Triangle are often linked not to supernatural forces, but to this beautiful, productive, and entirely natural sea. The Sargasso is not a trap or a danger. It is a cradle of life, a vital part of the ocean's functioning, and a place of extraordinary ecological richness. When early sailors spoke of being becalmed in the Sargasso, they were experiencing a natural phenomenon, the doldrums, areas of light winds that occur in certain parts of the ocean due to atmospheric circulation patterns. These calm zones have always been challenging for sailing ships, but they are not mysterious. They are predictable features of the Earth's climate system. As you continue your journey towards sleep tonight, consider the slow drift of sargassum across the surface of the sea. Imagine the tiny creatures that make their homes in those golden fronds. The young turtles finding refuge, the baby fish growing strong, the larval eels beginning their years-long journey to distant rivers. All of this is happening right now, quietly and continuously, in the middle of the Atlantic. The Bermuda Triangle, far from being a place of dread, encompasses some of the most productive and life-supporting waters in the entire ocean. Let us talk now about the role that modern technology plays in making travel through the Bermuda Triangle safer than it has ever been. In the days of Columbus, or even in the early 20th century, when Flight 19 disappeared, navigators had only the most basic tools to guide them. A compass pointed north, but as we have discussed, magnetic variation could cause errors. Sextants allowed sailors to determine their latitude by measuring the angle of the sun or stars above the horizon, but this required clear skies and considerable skill. Dead reckoning, the practice of estimating your position based on your speed and direction of travel, could accumulate errors over time. There was no way to communicate with people on shore once you were out of sight of land. If something went wrong, you were on your own. Today, the situation is entirely different. Global Positioning System satellites, a network of spacecraft orbiting high above the Earth, allow anyone with a GPS receiver to know their exact position anywhere on the planet to within a few meters. These satellites broadcast timing signals that receivers on the ground or sea or in the air can use to calculate their location. The system works regardless of weather, time of day, or location. A ship captain or aircraft pilot traveling through the Bermuda Triangle today knows precisely where they are at all times. There is no chance of getting lost, no risk of mistaking the Bahamas for the Florida Keys, as Lieutenant Taylor did in 1945. Weather forecasting has also advanced dramatically. Meteorologists now use satellites to monitor storm systems as they develop, tracking hurricanes from their birth as small clusters of thunderstorms off the coast of Africa, all the way across the Atlantic. Computer models predict where storms will go and how strong they will become, usually with considerable accuracy. Ships and planes are warned days in advance if a hurricane or tropical storm is approaching their route, giving them time to change course or delay their journey. Radar allows pilots and ship captains to see areas of heavy rain and turbulence from many miles away, so they can steer around dangerous weather. The white squalls and sudden storms that once took sailors by surprise are now visible on radar screens long before they pose a threat. Communication technology has transformed safety at sea as well. Every commercial ship and aircraft carries multiple radios, allowing constant contact with air traffic controllers, Coast Guard stations, and other vessels. If a problem arises, help can be summoned immediately. Distress signals are automatically transmitted if a ship or plane goes down, giving search and rescue teams a precise location to begin their search. Emergency locator beacons, life rafts equipped with GPS transmitters, and satellite phones mean that even if the worst happens, survivors have a much better chance of being found quickly. Aircraft have become vastly more reliable as well. Modern planes are built with redundant systems, meaning that if one component fails, a backup is ready to take over. Engines are tested exhaustively before being put into service, and they are monitored continuously during flight for any signs of trouble. Maintenance schedules are strict and carefully followed. Pilots receive extensive training, including time in flight simulators, where they can practice responding to emergencies in a safe environment. The aviation industry has learned from every accident and incident, incorporating those lessons into safer designs and better procedures. As a result, flying today is safer than it has ever been. The chances of being in an aircraft accident are extraordinarily low, far lower than the risks of driving a car. Ships, too, have benefited from technological advances. Modern vessels are built with strong hulls designed to withstand rough seas. They carry sophisticated navigation equipment, radar, sonar, and electronic charts. Weather routing services help captains plan the most efficient and safest routes, taking into account current and predicted weather conditions. Cargo is secured properly to prevent shifting in heavy seas. Crews are trained in safety procedures and emergency response. The maritime industry, like aviation, has a strong safety culture, constantly working to identify and mitigate risks. All of these improvements mean that travel through the Bermuda Triangle today is routine and safe. Thousands of ships and aircraft pass through the region every week without incident. Cruise ships carry vacationers to the Caribbean. Cargo vessels transport goods between North America and South America. Private yachts sail from Florida to Bermuda and back. Commercial airlines fly overhead on routes connecting cities in the United States with destinations in the Caribbean and Latin America. The skies and waters are busy with traffic, and the vast majority of these journeys are completed without any problems at all. It is worth taking a moment to appreciate the achievement this represents. For most of human history, ocean travel was dangerous and uncertain. Sailors knew that they might not return from a voyage. Ships were lost to storms, navigational errors, disease, and countless other hazards. The ocean was vast, powerful, and indifferent to human life. Today, while the ocean still commands respect, we have developed the knowledge and tools to navigate it safely. The Bermuda Triangle is no exception. It is simply another part of the ocean, and we cross it confidently because we understand it. There is something soothing in this progression from fear and uncertainty to knowledge and competence. The Bermuda Triangle legend arose during a time when we had less understanding of the ocean and less ability to protect ourselves from its dangers. As our knowledge has grown, the mystery has faded. We now know that there is nothing unusual about this part of the Atlantic. The disappearances that fueled the legend were the result of the same factors that cause losses anywhere in the ocean, and those factors are now much better understood and managed. The Bermuda Triangle, in a sense, is a story about how science and technology can replace fear with confidence. Let us consider some of the other creatures that inhabit the waters of the Bermuda Triangle, because the more we learn about the life in this region, the more we see it as a place of vitality rather than danger. Sharks are common here, as they are in most tropical and subtropical waters. The Caribbean reef shark, a sleek grey predator, patrols the coral reefs looking for fish. Despite its fearsome reputation, this shark is generally not aggressive toward humans. It is a necessary part of the reef ecosystem, helping to keep fish populations in balance. The nurse shark, a bottom-dwelling species, is even more docile, spending much of its time resting on the seafloor. Divers often encounter nurse sharks and can approach them closely without any danger. The great hammerhead shark, one of the most distinctive fish in the ocean with its bizarre hammer-shaped head, also swims in these waters. This head shape, which looks so strange to us, is actually a sophisticated sensory organ. The shark's nostrils, eyes, and electroreceptive organs are spread across the wide expanse of its head, giving it an enhanced ability to detect prey. Hammerheads feed primarily on stingrays, which they pin to the seafloor with their heads before eating them. They are powerful and impressive animals, but like most sharks, they are far more interested in their natural prey than in humans. Rays are common in the Bermuda Triangle as well. Stingrays glide along the sandy bottom, their flattened bodies rippling like undersea kites. They have venomous spines on their tails, which they use for defense, but they are generally peaceful animals that prefer to avoid conflict. Manta rays, the giants of the ray family, can have wingspans of 20 feet or more. These enormous creatures are filter feeders, swimming through the water with their mouths open, straining out tiny plankton and small fish. Watching a manta ray swim is like watching a bird soar underwater. They move with grace and power, their wing-like fins beating slowly as they glide through the blue. Smaller fish fill every niche in the ecosystem. Butterfly fish, with their bright colors and delicate fins, feed on coral polyps and sponges. Parrotfish, which we have mentioned before, are crucial for the health of coral reefs. As they scrape algae from the coral with their beak-like mouths, they also ingest small pieces of coral skeleton. These pieces are ground up in the fish's digestive system and excreted as fine white sand. A single large parrotfish can produce hundreds of pounds of sand in a year. The white sand beaches that are so prized in tropical locations are, in large part, the product of parrotfish digestion. It is a reminder that ecosystems are full of unexpected connections, and that even what seems like waste is part of a larger cycle. Barracuda, long silver fish with razor-sharp teeth, hunt in the open water around reefs. They are fast swimmers and efficient predators, capable of quick bursts of speed to catch prey. Moray eels hide in crevices in the reef, their heads poking out, mouths opening and closing as they breathe. These eels look menacing, but they are actually quite shy and will retreat into their holes if approached. At night, the reef comes alive with different creatures. Octopuses emerge from their dens to hunt for crabs and shellfish. Lobsters venture out from under ledges. Squirrelfish, which hide during the day, swim actively at night, their large eyes adapted to see in low light. The deep waters beyond the reefs are home to even larger creatures. Tuna, powerful and streamlined, cruise through the open ocean in schools, hunting smaller fish. These are the same tuna that are fished commercially and that appear on dinner plates around the world, though wild populations have declined significantly due to overfishing. Billfish, including sailfish, marlin, and swordfish, are among the fastest swimming fish in the ocean. Sailfish can reach speeds of nearly 70 miles per hour in short bursts, using their speed to catch prey and escape predators. Their long pointed bills are used to slash through schools of fish, stunning or injuring prey before eating them. Porpoises and dolphins, which we have discussed, are mammals, not fish, and they are among the most intelligent animals in the ocean. Scientists have studied dolphin communication, social behavior, and problem-solving abilities for decades, and they continue to be amazed by what these animals can do. Dolphins recognize themselves in mirrors, showing a level of self-awareness that is rare in the animal kingdom. They use tools, for example, wearing sponges on their beaks to protect themselves while foraging on the rocky seafloor. They cooperate with each other in complex ways, working together to herd fish, protect young, and defend against predators. They even seem to have distinct regional cultures, with different pods learning and passing on different behaviors. In every way, dolphins are remarkable. Whales, the largest animals ever to have lived on Earth, migrate through the waters of the Bermuda Triangle. We have already mentioned humpback whales and North Atlantic right whales, but there are others as well. Sperm whales, the largest toothed whales, dive to extreme depths to hunt giant squid. These dives can last over an hour and reach depths of more than 6,000 feet. The whales use echolocation, producing powerful clicks that bounce off prey in the darkness, allowing the whales to navigate and hunt in complete blackness. Pilot whales, which are actually large dolphins despite their name, travel in tight-knit family groups. Blue whales, the largest animals on Earth, can grow to over 100 feet in length and weigh more than 200 tons. A blue whale's heart is the size of a small car, and its blood vessels are wide enough that a human child could crawl through them. These magnificent creatures feed on tiny krill, filtering millions of the shrimp-like crustaceans from the water with baleen plates in their mouths. All of this life, all of this complexity and beauty, exists in the waters that we call the Bermuda Triangle. To think of this region as a place of death and mystery is to miss the reality entirely. It is a place teeming with life, full of movement and energy, a vibrant part of the global ocean that supports countless species and plays a critical role in the functioning of marine ecosystems. When we shift our perspective from fear to understanding, the Bermuda Triangle reveals itself as a wonder rather than a threat. Human activity in the Bermuda Triangle extends back hundreds of years. Beyond the famous disappearances, there is a rich history of exploration, trade, and cultural exchange in this region. Indigenous peoples lived on the islands of the Caribbean for thousands of years before European contact. The Taino people inhabited Puerto Rico, Hispaniola, Cuba, and other islands, building societies based on fishing, agriculture, and trade. They navigated the waters between islands in carved canoes, traveling routes that they knew intimately. For them, this was not a triangle of mystery, but simply home, a familiar seascape that they understood and respected. When European explorers arrived in the late 15th century, the Caribbean became a focal point of colonial ambition. Spanish conquistadors sought gold and established settlements. English, French, and Dutch traders and settlers followed. The islands became valuable sources of sugar, tobacco, and other crops, cultivated on plantations worked by enslaved Africans brought across the Atlantic in one of history's greatest atrocities. Ships carrying goods, people, and wealth crisscrossed the waters constantly. The Caribbean was not a mysterious or empty place. It was a center of global commerce and human suffering, a place where cultures collided and mixed, creating new societies that blended African, European, and indigenous traditions. Piracy flourished in the Caribbean during the 17th and 18th centuries. The scattered islands and numerous bays provided hiding places for pirates who preyed on the merchant ships traveling between Europe and the Americas. Famous pirates like Blackbeard, Calico Jack, and Anne Bonny sailed these waters, attacking ships and taking their cargo. The pirates were both feared and, in some accounts, romanticized. But the reality of piracy was often brutal. Naval forces from European powers eventually cracked down on piracy, and by the mid-18th century, the golden age of piracy had ended. but the stories remain a colourful part of the region's history. During World War II, the Bermuda Triangle area was strategically important. German submarines prowled the Atlantic, attacking Allied shipping. Bermuda served as a base for the Royal Navy and later for US forces. Patrol aircraft flew from Florida, Bermuda, and Puerto Rico, searching for submarines and escorting convoys. Some ships and planes were indeed lost during the war, attacked by submarines, or suffering from the hazards of wartime operations. These losses were not mysterious. They were the tragic but understandable result of military conflict. In the decades since World War II, the Bermuda Triangle region has become a major tourist destination. Millions of people visit the Caribbean every year, drawn by beautiful beaches, warm weather, and clear waters. Bermuda, with its pink sand beaches and British colonial architecture, attracts visitors seeking a blend of natural beauty and cultural charm. Puerto Rico offers a mix of historic sites, vibrant cities, and tropical landscapes. The Bahamas, with hundreds of islands and cays, is a paradise for beach lovers, divers, and boaters. All of this tourism depends on safe, reliable travel through the waters and skies of the Bermuda Triangle. And that travel happens every day, without incident, proving again that this region is no more dangerous than any other. The economic activity in the Bermuda Triangle is substantial. Shipping lanes carry goods worth billions of dollars. Cruise ships bring economic benefits to the ports they visit. Fishing, both commercial and recreational, supports livelihoods throughout the region. The islands are home to millions of people whose lives are as ordinary and mundane as lives anywhere else. They go to work, raise families, celebrate holidays, and pursue their dreams. To them, the Bermuda Triangle is not a legend or a mystery. It is simply where they live. Understanding the reality of the Bermuda Triangle means recognizing all of these layers of history, ecology, and human activity. It is a place shaped by natural forces like ocean currents and weather patterns. It is also a place shaped by human choices, by the routes we travel, the technologies we develop, and the ways we interact with the ocean and each other. The legend of the Bermuda Triangle tells us more about ourselves, about our tendency to create mysteries and our attraction to the unknown, than it tells us about the ocean. As the night deepens around you and your breathing slows, let the truth of the Bermuda Triangle settle gently into your mind. There is no curse, no supernatural force, no portal to other dimensions. There is only ocean, beautiful, powerful, and full of life. There are currents that flow according to the laws of physics. There is weather that forms from the interaction of air and water and energy. There are creatures great and small, living out their lives in cycles that have continued for millennia. And there are people, traveling through this region safely, going about their business, proving every day that understanding conquers fear. The scientists who study the ocean continue to learn new things about the Bermuda Triangle region. They map the seafloor in greater detail, discovering underwater mountains, valleys, and geological features that were unknown until recently. They track the movements of marine animals, using satellite tags to follow turtles, sharks, and whales as they migrate thousands of miles. They study ocean currents and how they change with the seasons and over longer timescales. They investigate the impacts of climate change on tropical waters, coral reefs, and marine ecosystems. All of this research adds to our knowledge and deepens our appreciation for the complexity and beauty of the ocean. Climate change is altering the Bermuda Triangle region as it is altering every part of the planet. Ocean temperatures are rising, and this has consequences for marine life. Coral reefs, which are sensitive to temperature, experience bleaching events when waters become too warm. Bleaching occurs when corals, stressed by heat, expel the symbiotic algae that live in their tissues and give them color. Without these algae, the corals turn white and are at risk of dying. Some corals can recover if conditions improve, but repeated bleaching events weaken reefs and make them more vulnerable. Scientists are working to understand which coral species are most resilient and how reefs can be protected and restored. Rising sea levels, driven by the expansion of warming water and the melting of ice sheets, threaten low-lying islands in the Caribbean and around Bermuda. Some of these islands may become uninhabitable if sea levels continue to rise, forcing communities to relocate. Stronger hurricanes, fueled by warmer ocean waters, pose increasing risks to the region. These are real challenges, not mysteries, and they require practical solutions based on science and cooperation. The ocean also absorbs carbon dioxide from the atmosphere, which helps to slow the pace of climate change, but has a consequence for marine life. When carbon dioxide dissolves in seawater, it forms carbonic acid, making the ocean more acidic. This ocean acidification makes it harder for creatures like corals, shellfish, and some plankton to build their calcium carbonate shells and skeletons. Over time, acidification could disrupt entire food webs and ecosystems. Understanding and addressing these problems requires ongoing research and international cooperation. None of this is mysterious or supernatural, but it is urgent and important. The Bermuda Triangle, like every part of the ocean, is part of a larger Earth system that we are changing through our actions. The real challenges facing this region are not about unexplained disappearances, but about how we manage human impacts on the environment and how we protect the ocean for future generations. As you lie here, feeling the softness of your pillow, the warmth of your blankets, and the gentle pull of sleep, you can take comfort in knowing that the world is knowable. The Bermuda Triangle was never a mystery that defied explanation. It was a story we told ourselves, a legend built on incomplete information and a human tendency to find patterns even when none exist. The real world, revealed by careful observation and scientific inquiry, is far more interesting than any legend. Think of the sargassum floating on the surface of the sea, providing homes for countless creatures. Think of the young turtles drifting safely within those golden mats. Think of the eels beginning their long journey to distant rivers, guided by instincts honed over millions of years. Think of the dolphins leaping through the waves, their sleek bodies cutting through the water with effortless grace. Think of the deep ocean trenches, where strange and wonderful creatures live in darkness and cold, adapted to a world we are only beginning to explore. Think of the coral reefs, vibrant cities of life built by tiny animals over centuries. Think of the Gulf Stream, that river of warm water flowing steadily northward, shaping climate and carrying nutrients and life across thousands of miles. All of this is real. All of this is happening right now, in the place we call the Bermuda Triangle. It is not a place of danger or mystery. It is a place of life, complexity, and beauty. It is a part of our planet, connected to every other part, governed by the same natural laws that govern everything else. Understanding this brings a kind of peace. The world is vast and sometimes unpredictable, but it is not capricious or malevolent. Cause and effect still operate. Patterns can be discerned. Knowledge can be gained. When ships and planes have been lost in the Bermuda Triangle, each loss has been a tragedy for the people involved and their families. But these losses were not the result of supernatural forces. They were the result of weather, mechanical failure, human error, or simply bad luck. The ocean is powerful and must be respected. Hurricanes are dangerous. Navigation errors can have serious consequences. Mechanical systems can fail, but all of these are risks that can be understood, anticipated, and mitigated. The Bermuda Triangle teaches us that with knowledge comes safety, and with understanding comes confidence. The beauty of the Caribbean and Bermuda is not diminished by the absence of mystery. If anything, it is enhanced. The turquoise waters are beautiful because of the way sunlight interacts with the clear, shallow seas over white sand. The vibrant colors of tropical fish are the result of evolution, adaptations that serve purposes like camouflage, mate attraction, or warning signals to predators. The warmth of the climate comes from the latitude and the moderating influence of the ocean. The diversity of life is the product of millions of years of evolution in a relatively stable tropical environment. None of these things require supernatural explanations, and understanding them does not make them less wonderful. In fact, understanding often increases our sense of wonder. To know that a sea turtle hatchling, barely the size of your palm, can navigate thousands of miles of open ocean to find a floating mat of sargassum is astonishing. To learn that an eel can travel across an entire ocean, transform its body multiple times, and return decades later to the exact place it was born is remarkable. To realize that coral reefs, which look like colorful underwater gardens, are actually built by animals so small you can barely see them, is humbling. The natural world is full of marvels that require no embellishment. As you feel yourself drifting closer to sleep, let go of any lingering fascination with the legend of the Bermuda Triangle as a place of danger. Replace it with appreciation for the Bermuda Triangle as it truly is. A beautiful, productive, and thoroughly normal part of the ocean. Let the gentle rhythm of the waves, rolling endlessly across the sea, lull you into rest. Let the image of sunlight sparkling on blue water fill your mind. Let the thought of dolphins swimming, turtles drifting, and seabirds soaring bring a smile to your lips. The world is a place of order and pattern, even when those patterns are complex and sometimes hidden from immediate view. The universe operates according to laws that we can discover and understand. When we encounter something that seems mysterious, the solution is not to invent supernatural explanations, but to investigate more carefully, to gather more evidence, to think more clearly. The Bermuda Triangle is a perfect example of this principle. What seemed inexplicable became understandable once people took the time to look at the actual facts. There is a lesson in this that extends beyond the Bermuda Triangle. Throughout history, people have attributed natural phenomena to gods, spirits, or supernatural forces because they lacked the knowledge to explain them any other way. Thunder was the anger of the gods. Disease was the result of curses. Eclipses were omens of disaster. But as our knowledge has grown, these supernatural explanations have been replaced by natural ones. Thunder is the sound of rapidly expanding air heated by lightning. Disease is caused by bacteria, viruses, and genetic disorders that we can study and treat. Eclipses are the predictable result of the moon passing between the Earth and the Sun. None of this diminishes the majesty of a thunderstorm, the importance of health, or the beauty of an eclipse. If anything, understanding deepens our appreciation. The Bermuda Triangle is part of this same story. It is a place where human imagination ran ahead of human knowledge, creating a myth that took on a life of its own. But knowledge eventually caught up, and the myth dissolved. What remains is the ocean, as it has always been. Powerful, beautiful, and entirely natural. Tonight, you can rest easy knowing that the mysteries we feared were never really mysteries at all. They were gaps in our knowledge, and we have filled those gaps with understanding. The Bermuda Triangle is safe to travel through. Millions of people do so every year without any problem. The waters are full of life, not danger. The weather can be challenging, but it is predictable and manageable with modern technology. The disappearances that created the legend have been explained, or, in many cases, shown to be exaggerated or fabricated. As sleep approaches, let your mind settle into this comfortable truth. The world makes sense. The ocean, for all its vastness and power, operates according to rules we can understand. Currents flow because of temperature differences and the Earth's rotation. Waves form because wind transfers energy to water. Hurricanes develop when warm, moist air rises and begins to rotate due to the Coriolis effect. Marine life thrives where nutrients and sunlight are available. All of this can be studied, measured, and understood. You are safe. The world is not a place of arbitrary danger or inexplicable vanishings. It is a place where cause and effect operate, where patterns emerge, and where knowledge brings mastery. The Bermuda Triangle is just ocean. And ocean, while it must be respected, is not something to fear. It is something to appreciate, to protect, and to celebrate. The stars are above you now, though you cannot see them through your closed eyelids. The same stars that guided ancient sailors are still there, wheeling slowly across the sky as the Earth turns. The constellations that Columbus saw are the same ones visible tonight. The moon, which pulls the tides and lights the night, continues its monthly cycle. The sun will rise tomorrow, warming the ocean, driving the currents, and energizing all the life that swims and floats and drifts in the sea. These cycles have continued for billions of years, and they will continue long after we are gone. There is comfort in that continuity, in knowing that the universe is vast and ancient and will endure. You have done enough for today. The questions about the Bermuda Triangle have been answered. The mysteries have been solved. The truth has been revealed. And the truth is more beautiful and more reassuring than any legend. Close your eyes now. Let your breath slow to the rhythm of the waves, in and out, rising and falling like the tide itself. Feel the weight of your body sinking into the mattress, held by the same gravity that holds the moon in its orbit and the Earth in its path around the sun. You are part of this world, this beautiful, comprehensible, natural world. You are made of atoms that were forged in stars billions of years ago. The water in your body has traveled through countless cycles of evaporation and rain, through rivers and oceans, through plants and animals, for eons. You are connected to everything, to the ocean, to the sky, to the life that swims in the Bermuda Triangle at this very moment. And like everything else in this world, you are subject to natural laws. But you are also capable of understanding those laws and finding your place within them. Rest now. Dream gently. Let the ocean of sleep wash over you, warm and safe and infinitely peaceful. The Bermuda Triangle is out there, somewhere in the Atlantic, and it is just ocean. Just water and salt and life and light. Nothing to fear, everything to marvel at. The world is knowable, the mysteries are solvable, and you, right now, in this moment, are safe and warm and drifting into the deep, gentle darkness of sleep. Good night.